as Matt was telling us, uh, we do the energy for the subsurface. So we have a center for subsurface energy and environment, where our work sort of intersects between the earth, the environment, and the energy. Uh, as you know, the demand for energy is growing because the population is growing. And currently, about 60% of the energy comes from oil and gas. But burning of oil and gas does produce CO2, which has environmental effects. So we got to minimize that. We got to minimize the greenhouse emissions. So in the US Department of Energy, this is a chart from them, and they're thinking of a future where you get your electricity from renewables, nuclear, uh, and fossil fuels, but you try to capture the CO2. That's called the CCUS, carbon capture and utilization and storage. You capture the CO2 the burning process creates, and you try to store that in underground. And also, you take the fossil fuel and convert that to hydrogen. So, such as if you have methane, you can convert that to hydrogen and capture the CO2. So, if you can do that, then you will have, you can meet your energy, and you can also minimize greenhouse gas emission. And so, a lot of the fuels will be converted to hydrogen, and there will be a hydrogen economy. So hydrogen can be used for chemicals, for heating, for metals production, and so on. And this hydrogen, if we use in that large scale, we have to store it. And that the large storages can only come from subsurface. So we have to also worry about storing hydrogen in caverns and permeable media underground. So this is the future we are going towards. So in our research, now I'm going to talk about my research, right? So in my research, here are some of the topics, and I'll describe them a little bit. So we are doing some work on carbon capture and storage. So we study injection of CO2 into aquifers and depleted oil and gas reservoirs, and how to store them, how do they transport when you inject them. So we study viscous fingering of CO2 inside reservoirs and how we can mitigate them through foams or WAG processes. We also try to convert CO2 gas into minerals. So mineralization, we make some minerals by reacting CO2 with certain things underground and above ground as well. So one of my students is looking at mineralization of CO2. We also work on hydrogen generation and storage. So in terms of storage, if we put the hydrogen into the underground reservoirs or caves, we have to worry about what kind of interaction it will have with minerals that's already present there, or microbes that may be present there. So we are studying reaction of hydrogen with our subsurface minerals as well as microbes that may be present there. We are also starting to look at how we can generate hydrogen from different subsurface components, such as minerals, as well as hydrocarbons that we may have. We also work on enhanced oil recovery, especially from unconventional rocks such as oil shales. So as you can see in this chart at the bottom, we, we can inject CO2 or other hydrocarbon gases into our fractured wells, and these gases can go in and mix with the oil there, and we soak it for some time. Then when we produce back, it can bring back some oil with it. So we have been trying to study these processes at high pressure and reservoir temperatures and try to understand the mechanisms and how we can optimize these processes. We also work on a phenomena called wettability alteration. A lot of the carbonate reservoirs tend to be oil wet. So because it's oil wet, oil sort of sticks to it. And when you do water flood, your recoveries are not very high. So it would be prudent to change the wettability to more water wet conditions. So we have come up with some chemicals that can do that. In fact, we just ran a 5-year project with Department of Energy doing that in a field and demonstrating that it can be done if you do it the right way. The other big project we have is chemical flooding of high temperature, high salinity reservoirs, carbonate reservoirs. So these are some reservoirs where you can inject surfactants and polymers and nanoparticles and try to mobilize the oil. But we got to make sure that at the high temperature, high salinity conditions, they're compatible with the brine that's there. So we systematically synthesize some surfactants and nanoparticles, and we study their phase behavior and transports, and we try to optimize this set of processes. So if you come and join my group, you'll learn about surfactants, nanoparticles, and polymers. We'll make foams, micromodules, and gels. You'll learn about how to model them through simulators such as UTChem. You will also use a lot of facilities that the university and our department has, such as X-ray CT, NMR, IFT, interfacial tension determination, core floods, gas chromatography, high pressure liquid chromatography, and such analytical stuff. So to do all this research, we need students, right? And we also need funding. We have some funding. And so you guys are the students. This is my group right now. And we have about 14 people in our group, about 11 PhD students, and some postdocs and research scientists. So with that, I'll conclude.